How about if while the battery is connected, I want to kind of keep it close to the first example, 60 volt. So now let's not disconnect the battery. Let's see here, 60 volts. No, that wouldn't work. Hold on. Let me change the battery to. Let me change the battery to something else. Let's say disconnect the battery, but connect it to another battery. Let's say it's a 30 volt battery. Oh, okay. So disconnect that original battery, which was 60 volts, connect the 30 volt battery with the 8 microfarad. And now connect it with the 4 microfarad. Okay, so you see what I did? The original example was this one, positive, negative. Here I completely disconnect that battery and I connect it to a capacitor. Now I'm saying disconnect it from that battery, connect it to a 30, and now bring in the second capacitor. Now is this more series or parallel, or how do we approach this? Oh boy, this is interesting. This one is a bit different. This guy is going to try to feed it, but this guy's original voltage starts at 60, right? This guy voltage starts going down. He pushes charge this way. So its voltage starts going down. This guy pushes charge this way. Ooh, how do we even proceed? Okay, let's do it this way. To learn this better, let's make this bigger than the original battery. So the original battery was 160, right? Let's make it 90 volts. Then we can attack if it's 30. So because the reason why is because if I made it 90, it's going to beat this guy, right? This guy is 60. It's trying to send the current this way. I want to make this guy beat that guy. Okay, so the current is going to flow this way now. You see? And then, so this is going to be positive. So this guy is going to send a certain amount of charge Q. It's going to build up even more charge here. And then that charge Q is going to go here. Okay. So then what's going to be the voltage of this guy? What's its original charge? We calculated that already, right? 480. The original charge of this was 480. So if this battery sends a charge Q to it, you get 480 plus Q over 8. So that's the voltage of that capacitor as a function of how much charge the battery gave it. What's the voltage of this guy? That one is going to be just Q over 4. Okay. So where do we go now? Do we set them equal to each other like we did in the other case? Okay. When this guy feeds this guy, the voltage of this 60 goes up and the voltage of that goes up. When the sum of their voltages equals 90, then it stops. Okay, this is more a series circuit. This is more series, not parallel. I mean, it's not the classical series, but it is more series. And the positives, the negative and the positive are touching. Yeah, this is more series. So then you add up their voltages. Okay. And then you solve for Q. Multiply this by 2. It's going to be 480 plus 3Q is equal to 90 times 8, 720. Q is 80 microcoulombs. Okay. So then what would be the voltage of this guy at the end? It's going to be 480 plus 80. 480 plus 80 over 8. That's going to be 560 over 8. It's going to be 70 volts, which means the other one should be 20 volts, right? Yeah, 80 over 4 is 20 volts. Yep. So this is more classical series. 70 plus 20 is 90. Have you seen these kinds of things, Daniel?
Maybe not like this quite, but
like where it's charged and.
Oh, a little bit.
You have?
Having just sort of touched on this, and it was like, okay.
Oh, okay. Now, how would it be if this was less than 60? That means it's the charge is actually going to go the other way, right? This is going to overpower the 60. Then it's going to go this way. Feed that guy. But maybe we don't have to worry about that. Maybe what we can do is solve it the same way that we did it now, but just set this equal to 30 and let the math tell us what's going to happen. Do you see? Then once the math tells us what it's going to happen, then we'll understand. You see? So that's why I wanted to do the case where it's greater than 60 first, then do the case where it's less. So let's just do it mathematically. Set it equal to 30. Then 30 times 8 would be 240, right? And then 240 minus 480. Aha. Let's see that. 3Q is equal to 240 minus 480. So then that's going to be negative 240. Q is equal to negative 80. Okay, so the math is telling us that the charge is actually flowing the other way. The battery is losing. I like that. So you got a battery, you got to lose. You can't compete with that guy. So then what's at the end? What's the voltages? V1 is going to be 480 minus 80 over 8, right? Which is what here? 480 minus 80 over 8. 400 over 8, that's 50 volts. And then what's the V2? Negative 80 over 4, right? Which is negative 20. Wow, that's weird. So what does it look like? It's at the end, it looks like this. 30. So this is 50 volts. and it stops like that. So it acts like a battery trying to push this way to there, right? And then this one acts like this. Because remember, the charge flowed this way to the positive, and then negative, negative, negative. And then it's like 20 volts. Oh, okay. So it's almost like this capacitor is trying to push this way. Oh, yeah, that makes sense. Yeah. This capacitor is 20 volts trying to push the current this way. And then this battery is also trying to push the current that way. Right. Together, they make 50. And then this guy is saying, no, I want the current going the other way, you know? So yeah, 50, 50, it stops. I like that. That's good. Yeah, it's wow how that worked. It makes sense now that you look at it like that. 230 and a 20 go with 50, compete with the 50. Wow. How about, let's say something like this, or let's say back to the 90. You can kind of see how you can have so much variety just based on this concept. So take the capacitor that was charged 60, now put it in parallel with that. Oh, does this one look parallel? We never answered it. Does this one look parallel, or no, I think this one, let's see, voltage of this minus 2. Well, you know what? It kind of looks like a more classic series in the sense that voltage of this minus the voltage of this equals this. I would say it's still series. More series than, no, hold on, Bolo. The negatives are touching. Oh, dang it. It's not series or parallel. This is more series. This one is the negatives are touching, but the voltages do add up to give you that. It's kind of in between, but I would say probably it's more series than parallel. Yeah, it's more series than parallel. But the negative, because the problem with this is it's a negative volts, negative. That's why their negatives are touching. But it's still, you could say 50 plus negative 20 gives you 30. Yeah. So I think it's more series. And this is more series. Definitely more series. Okay, so then this one is definitely going to be parallel. Yeah. So this is uncharged. So let's say, go back to the case where it's 90. How do we do that? This is originally 60. This guy feeds this guy. Some charge comes here, Q1. Some other charge comes here, Q2, until they reach the same voltage, and it stops. In other words, this has to reach a voltage of 90, and this has to reach a voltage of 90. Oh, okay. In this case, we already know the voltage that each one has to reach because it is a classic parallel. So what does Q1 have to be? So this one is going to be 480 plus Q1 over 8. Was it 8? Yeah, over 8 is equal to 90. It's almost like you solve them independently of each other, you know. Okay, and then you say 480 plus Q1 is 720, and Q1 is equal to 240 microcoulombs. So the battery has to send at least 240 microcoulombs to this guy, and then how much charge does it have to send to that guy? Okay, then you've got here Q2 over 4 is equal to 90. Q2 is 360 microcoulombs. I think this one is easier, huh? So then the total charge supplied by the battery is going to be what? 360 plus 240, 600 microcoulombs. So here you're not so much solving for the voltage of each one, because you already know they have to reach 90. But you're just solving, the problem might say, what's the total charge supplied by the 90 volt battery, right? So this one was really easy, I think. If it's 90, it's just going to supply this much charge, and then they're both happy. They're both 90. Well, what if it's 30 then? Okay, that one might be a little bit more tricky. Now this has to go down to 30 and stop, and then this guy has to go up to 30 and stop, right? Because this guy starts at 60. This guy goes down, and then this goes up. So maybe we can again solve it like this, just change it to 30 and 30, then let the math tell us what's going to happen. Do you see? Okay, so then 480 plus Q1 over 8 is 30. Q2 over 4 is 30. So see, if it's a harder situation like 30, then I'm letting the math dictate, okay, to teach us what happens. This is where sometimes the math will help you. Okay, so then you'd have 480 plus Q1 is 240. Q1 is negative 240. And then Q2 is 120. Okay, hold on. So therefore, this guy, so you see what happened? Q1 is negative 240. Q1 is negative 240. And Q2 is 120. Okay. So this guy, remember originally how many? It had 480 microcoulombs. Okay, 480 microcoulombs. So then 240 of that is going to flow out of that capacitor. It's going to discharge 240. 480. Out of the 480, it's going to drop down to 240, and 240 is going to go. Then the 240 is going to split. 120 of it is going to go this way. 120 of it is going to go that way and feed the other capacitors. So it's almost like this capacitor, this capacitor is telling the battery, hey, you stop, I'm going to do all the work here. You don't need to do anything. I'll meet you halfway. So it's discharging, it's feeding this guy 120 microcoulombs. This guy goes, this guy reaches 30 volts. It's fine. Okay. And then its charge goes down to 240. So now it's also at 30 volts. 30 volts. And then that extra 120 goes where? It goes here and goes through the battery and just sort of, should I say? It goes against the flow of the battery. So it goes towards the, see what happens when charge flows this way. It basically goes to the positive plate. But of course, you don't change the voltage of the battery. It just kind of gets absorbed into the battery. Just like we say the battery feeds and then stops. Basically, that 120 goes this way and just gets absorbed into the battery's mechanism. And then that's it. It just stops. So that 20 doesn't really do anything. It just gets dissolved. It gets combined with the battery's mechanism. Let's just say it that way. Okay, so you see what I mean? So in this case, therefore, this guy does the majority of the, actually it does all the work. It feeds that guy and it feeds that guy. Cool, cool, cool. Oof. So you can kind of see how these kind of questions really test your knowledge to see what's happening with capacitors and batteries and series and parallel. Cool stuff. I like it. Nice topics. Okay.